In this lesson, we're going to be taking a look at solving exponential equations. So what we're going to find in solving exponential equations is that one of the skills that's going to come in handy quite significantly is the ability to convert from exponent form into logarithmic form. Well, remember from Unit 2, one of the things we looked at was how to evaluate logarithms and exponents, and from Unit 1, how to convert back and forth between exponents and logarithms. So reminding you really quick, we've got y equals b to the x is the same exact thing as x equals log base b of y. Hopefully we'll remember that from previous lessons and being able to convert back and forth between exponential form and logarithmic form. So let's practice that really quick, going from exponential form here into a logarithmic form. So p to the h equals j. What does that look like in logarithmic form? Well, in logarithmic form we have x. X is the exponent piece for us, that's the h. So h is equal to log base b. B is the base value for us, that's the p. So log base p of y. Y is the piece by itself, the constant, the j in our case. So p to the h equals j is converted into log form as h equals log base p of j. Remember, the shortcut is start with the exponent h and work your way down. H equals log base p of j. If I think about that for this next one, start with the exponent x equals log base, what is the x on? R. So log base r of h. So this converted from exponential form to logarithmic form is x equals log base r of h. So let's see the context in which being able to do that conversion is helpful. It says here, solve the following equations. Okay, we have an exponential equation here. The first question is, why is this exponential? The answer is because the variable I'm solving for is the exponent. It's not down in the base area with everything else, like 3x plus 6 equals 5. Right? The x is down in the same level as everything else. In our case that we have here, the x that we're trying to solve for is the exponent. So how does being able to convert from exponential to logarithmic form prove to be useful? Well, here's what we want to do. We want to do everything to the equation that we're normally used to doing. For instance, subtract 17 from both sides, because we're trying to solve for x, which means we're trying to peel everything away from the x value so that it's all by itself. That leaves us the 3 times 4 to the x is equal to, let's see, 73 minus 17 is 56. Okay. Now I can divide the 3 away. I can divide by 3 because the 3 is connected to everything else through multiplication. So that's 4 to the x is equal to, let's see, 56 divided by 3 is a fraction. It's approximately 18.67. Okay, so here's the point at which we really haven't known what to do yet. Now some people might say, why can't we just divide by 4? It might look like that would be a good idea to do, but you can only undo something through division if it's being multiplied by everything else. And the 4 is not being multiplied by x. This is not 4x equals 18.67. It's 4 to the power of x. If it was 4 times x, I could divide the 4 away. But it's not 4 times x. It's 4 to the power of x. So what we're going to find out is a very useful thing is to, at this point, once I've peeled everything away that I normally am able to peel away through addition and subtraction, multiplication and division, is to convert this from exponential to logarithmic form. So remember, start with the exponent. For us, that's going to be x equals log base. So x equals log base 4 of the 18.67. Log base 4 of 18.67. Okay? So by converting this from exponential form into logarithmic form, take a look at what I have. I have my entire equation solved for x. X is all by itself. So all that I need to do now is what we've learned to do in Unit 2, and that's evaluate this logarithm right here. So this becomes x equals, let's see, I'm going to do log of 18.67 comma base value of 4. Or for those of you with the older, remember the change of base formula, you can do this as the log of 18.67 divided by the log of 4. And I end up with a 2.11. So x equals 2.11. So because the exponent that I was trying to solve for was, or the variable I was trying to solve for was in the exponent location, we had a unique scenario in order to be able to get that value, that x value, out of the exponent location, I had to convert it into logarithmic form. And once I did that, I can evaluate the logarithm left because the variable is no longer with it. And I was able to then solve x equals 2.11. So we've got two more examples I'd like to work through just to make sure that we have this idea solidified. We've got 7 to the power of x minus 8 plus 32 is equal to 187. So again, go ahead and start doing the things that we're normally used to doing when solving an equation. So I'm going to start by subtracting 32 from both sides. That gives me x, or 7 to the x minus 8 is equal to, let's see, 187 minus 32. I'm getting a 155. Okay, so subtracted 32 from both sides. This is an exponential equation because the variable I'm trying to solve for is in the exponent, which means at some point I'm going to have to convert, like I did in the previous one, from exponential form into logarithmic form. The question is, when do I do that? Now, some people might be tempted, oh, add 8 to both sides. I can't do that because the 8 is up in the exponent location. And here's the other question, can I divide by 7? And the answer again is no, because it's not 7 times x minus 8, it's 7 to the power of x minus 8. So it is at this point that we convert from exponential form into logarithmic form. Now, notice that the exponent isn't just a single value or a single variable, it's x minus 8. So just treat that whole thing as one chunk. So remember, when we convert from exponential to logarithmic form, you start with the exponent. So x minus 8 is equal to log base, whatever the exponent is on. That's my 7. So log base 7 of 155. So I've got x minus 8 equals the log base 7 of 155. Well, we know how to evaluate the log base 7 of 155, so I'm going to do that. Log of 155 with a base value of 7, and I'm getting x minus 8 is equal to 2.59. 2.59. Now, unlike the last problem, this is where we were done. But my exponent was more than just an x this time. It was an x minus 8. So to finish solving for x, I now need, after I've evaluated this logarithm, to add 8 to both sides. When I do that, I end with x equals 10.59. And that's the solution to this exponential equation. So don't forget, it's do what we're normally used to doing first, adding and subtracting and multiplying and dividing if you can. And then at the point at which there's nothing left to do, you have to convert from exponential form into logarithmic form, and that allows you to finish solving for the variable. So let's do one final example together. Again, we have an exponential equation. Again, we know that because the variable x that I'm going to be solving for is in the exponent location. But let's go ahead and do all of our addition, subtraction, multiplication, division. I see a 6 right here that I can subtract from both sides. That gives me negative 2 times 5 to the 3x minus 7 is equal to, see, subtracting 6, I believe that's going to be negative 831. Okay. Oh, and now I have a negative 2 times 5 to the 3x minus 7, so I can divide by negative 2 now. So that's 5 to the 3x minus 7 is equal to, so we do the negative 831 divided by negative 2, and I end up with 415.5. Okay. Now, can I divide by 5? No, because it's not 5 times 3x minus 7. It's 5 to the power of 3x minus 7. I can't add 7 to both sides or divide by 3 yet because that's in the exponent location. This is at the point at which we convert from exponential to logarithmic form. Now again, we have a big chunk of stuff as our exponent, treated as one piece. So again, converting to log form, we start with the exponent. The exponent is 3x minus 7 is equal to log base whatever the 3x minus 7 was on. That's the 5. So log base 5 of 415.5. Okay. Good. So the x is no longer in the exponent, and I can evaluate this logarithm. So it's the log of 415.5 with a base value of 5. And I'm getting 3x minus 7 is equal to 3.75 rounded to 2 decimal places. Okay, but just like the previous one, I'm not done. I still have to solve for x, but now I can deal with the 3 and the negative 7 because it's no longer in the exponent location. So I can add 7 to both sides. 3x equals, it's going to be a 10.75. Okay. And then divide by 3. And that's going to be a 3.58. 3.58. So the solution to that exponential equation is 3.58. So again, can't stress this enough, do what you can by adding and subtracting and multiplying and dividing things away. But there always comes a point at which to finish solving an exponential equation, you have to be able to convert it to log form. And from that point, evaluating the logarithm, you can then finish off solving for that variable.